Welcome everybody to this edition of a College Credit webinar series, Creating Your First Java Application with Apache Cassandra. I am very excited to have Apache Cassandra MVP Brian O'Neill with us today. You can follow Brian at BO'Neill42 on Twitter, and I strongly recommend reading his blog as well. Just a couple of housekeeping items. This is going to be a very hands-on presentation today. Brian is actually going to walk us through how to create our first Java application, so there's a lot of screen sharing going on. We will hold our questions until the end of the presentation, but Brian is reserving a lot of time to answer your questions today, so please use the WebEx Q&A panel to ask your questions, and I will pose them to Brian at the end of today's webinar. So without further ado, I would like to welcome Brian O'Neill.
Hello, everybody. Can you hear me okay?
We can hear you great, Brian. Thank you.
All right, perfect. All right, so I'm going to start by sharing desktop so everybody can see what I'm doing. And hopefully this is going to be a fun, as Christian said, hands-on presentation. So we are actually going to build an application. So let's get started right away. So today our challenge is going to be to help Santa Claus. So keeping with the spirit of the holidays, we're going to build a nice and naughty list for him that is globally scalable. And then we're also going to keep track of which children want what toys. And this came from just a little background. I'm lead architect at Health Market Science, where we are in the master data management space for the healthcare industry. So we bring in, over 2,000 feeds of data, all with different schemas. We put them together and we track, the good doctors out there, the bad doctors, the dead doctors, in order to determine who's eligible to write certain prescriptions. And then, we help the pharmacies with that. So, without further ado, so that translates almost identically to what we want to do today, which is build this scalable naughty list. So we'll get deeper into the data modeling aspect of it, but the irony here is I looked it up and there are 1.9 billion children in the world. And with Cassandra, that'll actually fit in a single row. Barely, but it'll fit there. So what we want to do is build an application that can allow children to log in and check their standing with Santa Claus. And then also, as Santa's flying around the world, he'll be able to query by country, state, and zip code which children are on the nice list and which children are on the naughty list. And he'll do that with some speed. So this should be fun. Let's get set up, though. So to install Cassandra, one of the great things about Cassandra is the ease of administration. To get set up, really all you need to do is uncompress the archive that you can get from here. Today we'll be using the 1.2 beta version, which is sort of cutting edge, but it is going to be release candidate ready soon. So I wanted to keep the content fresh and actually show everybody some of the new features that are available. So I decided to go with 1.2. So if we jump over to the terminal real quick, let's see. I'll shut it down just so I can show you guys. So, I usually keep a bunch of the Cassandra versions available here. So I actually have 1.1.2, 1.12, 1.15, and 1.20. And really all I did is take the tarball into this directory and type unzip. For time reasons, I'm going to not download it right while you're watching, but then I just create a symlink. And then start her up, all you do is type bin Cassandra. But what we want to do and what I want to show everybody, get more into this later, but if you get the vanilla tarball down, you're going to want to change a couple things, usually. The most important of which, if you're going to try and do this at home, is this start native transport. With 1.2, it's actually pretty exciting. There's an entirely new transport to support CQL development, and we'll be going into what that is in a little bit. But in order to enable that, you're going to want to go into the Cassandra YAML itself, and you'll see start native transport true. So that will start the new transport that is not dependent on thrift on 9042 in this case out of the box, and then you'll be ready to do this at home. So if you're following along at home, go ahead and download, unzip, change that value, and then you can do bin Cassandra-F. And usually when I'm in development mode, I just leave it in the foreground just in case. So, and you can see it fire up pretty quick right there. So moving along. Next we want to talk about the data model. And I'm not going to go too deep into data modeling. I have a link here when we share the slides that Aaron Morton did a great demonstration on data modeling. So I recommend everybody go take a look at that. It is really important to understand the data model that Cassandra has underneath of it though. And as we'll see today, there are two views into the Cassandra world when you start to look at CQL. One is from the CQL perspective, which looks a lot like regular tables that you see in a relational database. And then another is from the persistence perspective, where how it's laid out in both rows and columns for Cassandra underneath. And the reason that's important is from the Java API perspectives, you actually get to see and interact with the storage model tightly. So when you ask for rows and columns, that's what you're going to get, and it's going to be Cassandra's versions of rows and columns. So what's all that mean? So at the top of the Cassandra's data model is the schema. And that used to be called key space. So in a lot of the Java APIs, you're still going to hear key space, and you're going to see those kinds of classes there. Within a key space, that's also where Cassandra has its security. So you can authenticate against a key space. So it's a lot like MySQL or any of the relational databases, how you can create your own schema. Within a schema, you have tables. They used to be called column families. So again, in the Java APIs, you're going to see the terminology column family. Over in the CQL world, they're going to use the table terminology. Okay, so that's all fairly standard. Now the fun part. So within a table, you can have rows. That's normal. But rows can have any arbitrary number of columns, and the number of columns can differ between rows. So that's pretty different and pretty powerful. So we're going to see how we can leverage that to do sort of indexing as we go through our schema here. And then you can look into the details of this a little deeper afterwards. But Cassandra treats data fairly opaque. It doesn't look into data. So really the only two mechanisms it has is it validates the bytes that you're giving it, that they're compatible with your table. So in the case of rows, it's really going to only validate your row keys. So it'll make sure that it's UTF-8, for example. There are other data types, but again, refer back to Aaron's presentation for more on that information. So then within rows, you have columns. And the key piece here is that columns are sorted. So you have to specify a comparator for your columns. The reason for that is that columns are sorted on disk, which is pretty important. Okay, so let's take that data model and now apply it to Cassandra's distributed architecture. And again, I'm not going to go into detail too much here, but it's important when considering how to lay out your schema. So in Cassandra, nodes form a ring, and what happens is that each of those instances starts up with an initial token, which gives it its location on the ring. Row keys, so your exact row key, are then mapped into that token ring. And that is how the data gets partitioned between the nodes. And then, like I said, all columns for a row are stored together on the disk. So let's take a quick look visually what this means. So if I have a row, Alice, Bob, and Eve, and these are the row keys, typically, and there are some cases where you don't need to do this, but if you're using random partitioning, which is the recommended way to go, these row keys are going to get hashed with an MD5 hash, or actually it's changing 1.2, but they're going to get converted into the token range, right? So here I'm just pretending that I have a range of 0 to 99. Alice, let's pretend, hashed to 50, Bob to 3, Eve to 15. They're actually going to be distributed unevenly, right, along this ring and in no particular order. So that's really important, that range searching across a set of rows is difficult in Cassandra because it could span all of your nodes, right? So traversing a key space in Cassandra will actually touch all of your all the nodes. There's some caveats to that for replication and such, but again, we're going to gloss over those a bit. So what I like to keep in mind from a Java head's perspective is that the Cassandra data model always maps to this in my brain, right? So it's a hash map where the row keys, the different segments of the hash, different rows in the hash, are distributed across machines. Then each row, right, is actually a sorted map of columns. Okay, so I can't emphasize this enough. This trips some people up. But if you boil it down to this, I think things are pretty clear. So the implications here are that a direct row fetch is fast, searching a range of rows can be costly, as I explained, and then searching a range of columns is cheap because they're all sorted on disk. So that's the background I think we need to start on our first app. Okay, so let's take a look at our schema. For this application, I'm suggesting, and let me also say that defining a schema for Cassandra is an art. And I think there's lots of great blog posts out there on recommendations on how you do it, but often you work backwards from the queries you want to support. So in this case, you know, we had those two use cases where I want to just be able to fetch the data for a child, and then I also want to be able to search at multiple levels of granularity to determine what children in a particular location are naughty or nice. So the first case is pretty simple. We're going to store all the children in the world, one row per child, one column per attribute. This maps almost exactly to what you're used to in the relational world. The second one, where we want to support queries by geographic location, we're going to have to get a little creative with. So we're going to take what's called a wide row strategy, and we will actually have one row per country is what I'm suggesting in this approach. And again, you could debate a bit because it is a bit of an art what the best approach is, but let's at least go along this path for a little bit here. So let's get down into the details of the naughty or nice list specifically, because I think the children table is pretty straightforward, but the naughty or nice list, again, is the one that's a little creative. So if we do one row per standing :country, right, so nice or naughty, and then USA or Ireland, it ensures all children in a country are grouped together on disk, right? So that's basically what we're saying. And then if we did one column per child using a compound key, and I'll explain more about what that is, it would ensure that all the children are grouped with each other if they are geographically close to one another, which is pretty neat. So you're actually dictating what the storage is on disk so that you can get speedy queries by designing your schema. So, you know, so I'll actually show this right here. So, so what's this mean visually for the naughty or nice list? So if I have 3 nodes in my cluster, first of all, I wouldn't be guaranteed that, you know, all 3 tables might end up on a single node. But it'd be quick to go, this is my row key, and then listed down are my columns. And each, you can see that these are in sorted order. And it would be fast for me to go grab all the rows that are of a certain zip because they would all be stored together, right? So a couple of things here, though, as we've done some very large, wide rows in our production environments, is for hot spotting. So let's say that you know, we are actually only going to have one row that has all the nice children in America in it. So if I had a Cassandra cluster of 50 nodes, right, only one of them would have that index on it. Now, there's some caveats to that where, you know, replication would spread that across, you know, as many replicas as you have, but you can get some unbalanced usage of your cluster. So that's a big warning there, so be careful. So let's keep going. All right, now we're going to get to do some hands-on stuff. So I'm going to flip over back to my command line, and let's take a look. I've got my schema right here. This is going to look awfully familiar, right, for relational people. So I'm just killing the key space if it exists and creating this key space here. Now, since I'm on a single node and I only have, you know, just this node to worry about, I don't have multiple data centers. All I need to specify for my key space is the replication strategy and how many replicas I want. So again, since I'm local, one replica is fine, and a simple strategy because I don't have multiple data centers. Again, I refer back to Aaron's presentation and some of the other information online for more information on that. So then, just like Relational World, you say which database you want to use, and then I'm going to create my two tables. And again, this looks awfully familiar, right? So all these guys with columns in the children table, and then I specify a primary key. And with compact storage, I'll just touch on quickly. With the advent of CQL, when I issue this statement, the SQL SH prompt, CQL creates the schema for me, but it has a lot of extra capabilities that it will adjust my schema slightly. And in this first example, since we're going to be using one of the Java APIs, I'm going to say with compact storage because that makes it the schema that I have here map better to the Java APIs. I will go into that more in a little bit, so let's keep going. And then I'm going to create my naughty or nice list. So here I only had one primary key, right? So that ends up being the row key. Here I'm declaring a set of columns, and every one of them is in the primary key. And we're going to see what the implications of that are in a second. And then I just got a bunch of insert statements for the children, insert statements for the naughty list. Now, people looking at this might, especially with a relational I, might say, whoa, that's a lot of data duplication. And it is. So I think that's one of the things I've had to get used to with Cassandra is the data duplication. But I think it's standard practice now to, you know, duplicate your data and denormalize and construct your schema to match your queries. So it's one of the things I've had to get used to. So now that we've taken a look at that, so all I really do is cat that into SQL SH. So SQL SH is the new SQL prompt, CQL prompt that is the I'd say recommended way to create and interact with schemas, makes sort of database administration a little easier. In the old days, we used Cassandra CLI, and I actually still use that. You're going to see why in a second. So let's just issue that command, and you're going to see Cassandra start working in the background. That's why it went purple. We're going to fire up CQL SH. Go take a look at my new fancy schema with some data. Let's start from children. So look, it's there. So that's not terribly impressive, is it? So, and look, that's there too. Okay, now when I did these select statements, so you saw I just ran the SQL SH. It went and did some fancy interpretation for me in CQL world. So as I said, I still use Cassandra CLI to go look to see what the actual layout of that information is going to be like within the cluster. So if we go in here and type list children, you know, CLI has many of the same capabilities of CQL when you're just looking at and inspecting schema. It also has some other more admin-y type functionality that you should take a look at. But right now, we're just going to take a look at our data. So when I say list, you'll see that this is exactly what we were saying. That you know, there's one row key per child. That'll distribute nice and even around the cluster, provided there aren't, you know, more M's, or sorry, that should distribute evenly around the cluster because it's all hashing, right? So, and then there's one column per attribute that I have, all good. Now, what's interesting is that if I go over to the naughty list, check this out. So it's what we wanted, one row key per standing and country. So you can see I've got Bart Simpson, Dennis, and Michael Myers, all naughty in the USA. Then over in Ireland, I got Colin O'Neill and Owen O'Neill. But you're going to see that all of that for the entity was squished into a single column name. There's actually no values here, which is interesting. So let me flip back to the PowerPoint and describe that real quick. So the SQL data modeling rules, everything, here's the key part, comes down to how you declare this primary key. All right, so the first primary key becomes the row key. So you can see we did standing by country there. Then subsequent components of the primary key form a composite column name. So basically what CQL did for me is it put these things together and stuffed them in the column name. Now in this example, I didn't have any non-primary key columns. But had I done that, it would also, for each one of those columns, create a new column. So for each data column, right, that you have that is not related to the key, it will, when I do a single write, it will write multiple columns, one for each of those types of data that I'm storing. So I'll give that a second to process. So because that's pretty important and pretty powerful, and we'll see how that translates over into the Java API world. Okay, so I sort of ran you through the two different views that we had, one from the CLI view, one from the SQL view. I just captured in the slides here. Now, one last thing related to the schema before we start hacking some code is the data model implications and what I can and cannot do with respect to CQL here. So if we go here, hopefully I got these right. So I'm going to go back into CQLSH. So you saw that I could easily do a select star from naughty list. Oops, sorry. Gotta get into North Pole, select star from naughty. Okay, so I can pull those back, but watch this. You'd expect to be able to do this where child ID equal to O'Neill. Sorry, taking too much code lately. Okay, so this error, right? So coming from relational world, you would have expected to be able to do this. But when you think about how it is laid out on disk, you got to guide Cassandra through getting to your data. So first you want to specify, you need to specify the row key. So let's do it, standing by country equal to nice USA. Right, so this will actually work because I'm telling it what the first place to go is, right? So now it can go, if we flip back, or just think about that image of the hash map, right? I'm telling it where to go in that first hash map. So this tells it which node to race to. Then I can add an additional clause on here, but even if I do this now, it still yells at me because I haven't told it where to go next in the sorted columns storage, right? So you actually have to progress through and go from your outer granularity down into, so that's good, and zip equals 94333, so that'll be happy, and child ID equals Richie Rich. There. So you can see it's happy, but you can't skip any of the intermediate components of the column name because it's literally searching down into the storage on the disk, which is all sorted by column, and basically what it's doing is refusing to do table scans for you. So, which I actually think is good. So, okay. So, can I move on here? Let's get over to code. All right. So this is the fun part. So I even hesitated to put numbers on this slide. Let me just say that this slide is all in my humble opinion. Okay, so your mileage may vary, and whom you talk to, they may give you different answers. One of the great parts about the Cassandra community is that it is incredibly active. It is well, you know, hats off to Jonathan and crew. They do a great job of wrangling the community, herding the cats, and we, as Java developers, you know, the ramifications of that are that we have tons of options for client development. So let me just race down through here because I want to keep going, make sure we have time for questions. So for people that know thrift or have heard the term thrift, that's the old RPC layer that goes to Cassandra. So, you know, thrift is used by a bunch of different projects to get really efficient RPC, and Cassandra has that. And I'd say, let me see, all except for maybe the bottom one of these Java APIs is built on thrift. So, you might have seen my bio. So, you know, we have a project called Virgil, which is a REST interface, and that's built on thrift as well. And thrift, because it's a tight coupling to Cassandra, I mean, it's the same, it basically just mimics the objects that are server side, client side, and allows you to call those methods on those objects client side. But it is tightly coupled to the server, which makes it fairly difficult to interact with. So if you're trying to choose a Java API, I would just bypass thrift. And it's still supported, but in the future we may see thrift go away. So Hector is probably the most production ready. Here at Health Market Science, I'd say 95% of our heavy duty code is written on Hector. So I've got 3 columns across the top here. You know, production readiness, potential, which means like, you know, there's some good stuff here that people might latch on to this and it might become something great, and momentum. So just, you know, how many people are using it, how many people are flocking to it, that kind of thing. So Hector, absolutely production ready. You know, if you've got mission critical apps, I'd go with Hector. Potential, a lot of people are gravitating more towards Astyanax these days, so you might want to go with Astyanax if you're looking for what the API might become. So Astyanax has a little more momentum than Hector, I'd say, and a tiny bit more potential. Kundera, I love what those guys are doing. It is a Cassandra implementation for JPA. So I've used it quite a bit. We do not have any Kundera production code. We do have Astyanax code. But it's getting there, right? So it's got a lot of potential and a fair amount of momentum behind it because you've got a lot of Java developers out there who are comfortable with JPA. So that might be another contender. Kundera is actually built on PLOps, I think. But we don't use PLOps at all in our house. And I think most people, if you're looking for a straight up Java API, gravitate more towards Hector and Astyanax. Firebrand is a newcomer. And to be honest, I've played around with it on my desktop, and I love what I see. So I think it's got a lot of potential. But again, Hector and Astyanax are sort of more widely used. PlayORM, another great contender. Dean's got some good stuff going on over there. And what he's bridging the gap, so you don't get joins in Cassandra either, right? So if you go listen to some data models. So he's building his framework to allow a lot of the capability that you had in relational world in a massively scalable way. So again, good stuff coming. Gora, another one of those. These guys are the ones, just sort of like Kundera, they're trying to build a API that spans the NoSQL databases. So it's getting there. So I'd say, I don't know this for sure, but Gora, if you look through the tutorials, they're mostly focused on HBase, but they also have a Cassandra. So you sort of get that feel when you go to use it. And then CQL driver, I'm going to come back to at the end of the presentation, hopefully. All right, so now we're going to get to the code. All right, so what's the first thing we need to do? So I'm going to flip over here, and I have all this code up on GitHub. I'll give you the link at the end. So let's go. So what's the first thing you need to do when you're going to go write an application? Well, you need to get connected to the database. So in this case, I've got a little Astyanax DAO class here. It takes a host, which is just a host name, and the key space I want to connect to. And for Astyanax, you got to give it a cluster name. That's really just for you, what you want to identify this cluster as for your application code. Then the key space, that should be fairly self-evident. And then what Astyanax is going to do underneath the covers is discover all the nodes that are part of that cluster. So you can tell it what to use to do that discovery, since we're locally. So ring describe, again, you'll know some of these from other presentations. But again, since we're local, I'm just going to leave that none. And then there's also connection pooling in here. So max connects per host, seed host, connection pool monitor. So this is a great facility to have. Again, so if you were interacting at a lower level, you would have to build a lot of this connection pooling and fault tolerance on your own. So here you can just configure it with the Fluent style here. So these are the key lines, right? So once I've identified where I want to connect, how I want to connect, and my connection pool, I start up the Astyanax context and I grab a key space from it. And then what I typically do is throw a line in here just to invoke a command in the key space, which will immediately validate that I'm good with the connection before I go on. So that's it. I put this, this actually should be an abstract class because I go ahead and implement it here. So if we go move down, make sure I'm not missing anything. If we go move down into the child DAO, it extends Astyanax DAO, and you can super just pass the host and key space. And let's take a look at how we write data. So again, really simple. I mean, you saw how many lines of code it was to get connected, and this is pretty much just as simple. And this is where Astyanax has a slight advantage over some of the other APIs in that the way the API was designed is pretty readable when you go and interact with anything. So to change things in Cassandra, it's done through a mutation. And you can put a batch of changes into a single mutation. So that's what you see happening here. So anytime you want to change something, go ahead and grab your key space, right, which is just the object from up here. I'm not going to saw that accessor on it. Down here, get key space, right? So get key space and you say prepare mutation batch. Now here I designed the signature of this method to be incredibly flexible, right? So I'm not even taking a child object at all. I just take a map of strings, and all I need to do is say mutation with row, right, where you specify your column family. I should say, sorry, I should say this. So I've got the table name up here declared as a static final string, that children table that we saw earlier. And what I need to tell Astyanax is what kinds of things are in this table, column for the columns, right? So we have string serializers here, which basically just says what the rows and columns are in that table. And it'll serialize them for me. We'll see more detail on that when we get to the composites. Okay, so this should be dead simple when you look at it, right? It's just adding the map of strings in as columns on this row, so row and columns, right? Exactly like the way I think about that data model from the Java perspective. So let's run over and give this a test. All right, so here we are. Let's actually, I should have shown the read first, just before we start mutating things. So read is right here. You can see how simple it is. So here I'm just reading an entire row, and you say prepare query, get row, execute, and then it's object for results column list, and I return that column list of strings. So let's go read real quick just to prove to ourselves that that works before we go mutating stuff. All right, so you can see what was I, let's get back to the test just to make sure. So Bart Simpson, right? So I was querying for Bart Simpson, got him back. I just have a log method down here that just cycles through the column list of the return values and outputs anything it gets. So there you go, that's a read, pretty easy. All right, so let's go ahead and write. So just for fun, I figured it'd be fun to throw the devil on the naughty list. But check it out. This doesn't even conform to our schema. So let's see what's going to go on here. So for the devil, he had no country, state, or zip, so I decided to throw in plane of existence on there. So let's run that unit test. All right. So this called the DAO that we were just looking at, that method that we were just looking at. So let's go take a look and see what happened to that data, because that's kind of crazy to do that. So we were interacting with the children table. Look at that. It had no problem inserting that. So what's crazy, though, is look, plane of existence did not get appended on here. All right? So again, there's two different views into the system right now. One is the CQL view, which has some metadata about what I should be putting into my table and what it should look like. And then let's quick flip over to Cassandra CLI again. Again, I still love flipping over here, because then this gives you the real view into how the data is laid out. Oops, sorry. List children. So let's see what that looked like. So check it out. So even though we didn't see it over in the CQL perspective, the plane of existence is there. All right? So let's go back over here and read demo child. Right? And you can see it came back just fine. So, you know, you're getting two different views here. So we did not, you know, it's kind of interesting for me even, you know, we've been using the Cassandra for a couple of years now. And in the advent of CQL, you get a very schema-ish feel to Cassandra, but you haven't lost any of your NoSQL, no schema power, especially from the Java API perspective. So that's something to keep in mind. Okay, so just for completeness, let me see. I think I have a delete here. So delete, you can see how easy it is. So mutation, just like before, with row, delete, deleting child. Run that. Boom. Let's take the devil off the list, and you can see gone. So again, I won't get into this. So you still see the row there, but it has no columns. So there's some behind-the-scenes stuff that Cassandra needs to communicate the actual deletion across the cluster. So that's why you sometimes see this there. Okay, so that's the child table. Now we're going to get sort of level up here. All right, so the child table, like I said, is incredibly straightforward. You can see how you could build an app off of that pretty easily. Now we're going to get into the fun stuff. And you saw that I didn't even create a child object to map there. I don't need to. But with the list, the nice or naughty list table, I'm going to use a list entry object that maps to the components in the columns, right? So that is or the columns in the table, right? And this, so if we go back over here and list naughty or nice, you can see, so this is the actual column name, right? And you can see there's multiple components to it. So what I did is I created a class that says in order, ordinal 0 or 1 and 2, what are the order of those components and what they're going to be. And then I can use this in my DAO. So where I had a string serializer in both these spots in the child table, now I have an entity serializer, which is declared right here, which is a composite serializer from Astyanax and is typed with list entry class. All right. So basically it's the same as it was before, except when I declare my column, I need to tell Astyanax that I have a composite column name. And here's my serializer for that. The rest is going to look almost identical. So, so let's try, and I forget who I'm reading here. Let me flip over. So let's just read all the values in nice USA. So as you can read the one row. See if that works. Okay, that's good. So that's the read. So you can see it's the exact same as before. Flip over to Cassandra Data. So the read got the result, passed it back, and in the list entry DAO test, I just have a log, again, statement. But you can see here that because it's typed, and I sort of like this with Astyanax, right? I get my actual object back. So it does the serialization into the exact object that I was going to use. So it's pretty convenient. So I'm actually using the object here and dumping the object. Now, this is the fun part as well. So here we're going to do a write. So we're going to put Hank down into our database, and I'm going to show you an interesting effect. So let's run this, and we're going to write a list entry. That's going to work just fine. So we will list, and you see Hank here? That's good, but check this out. I always forget to go to the North Pole first. And I'm doing tab completion here, so it's nice. Look at that. That's terrible. So what happened there, and this tripped me up. So if we go over to the Cassandra logs, I actually have an array index out of bounds exception over in Cassandra, and this is the actual server, right? And then that manifests itself as a T-socket read 0 bytes. And it took me a while the first time, so there's a blog post on this so other people don't get tripped up, to figure out what that was. Got to go to the North Pole. And if you look here, there's no colon on the end of Hank. So the way that CQL, and there's a great, I actually have the blog link there's a blog by Jonathan and another one, I forget who wrote the other one, about the differences between script and CQL. But the way that CQL constructed this is it's ready to put a data column on the end of here. So we happen to construct a schema that has no data columns. So what we actually need to go do, first of all, yeah, so let me remove Hank real quick and show you that. So now Hank's gone. Get back over here, full, select, and I can now select again. That's good. So my table is back to normal. And what you have to do over on the Astyanax side is create another ordinal value to support that extra spot in the column name. So, so I'm going to drop that in there, and then we're going to write again. Beautiful. Let's be ambitious and see if Hank comes up here. He does. So you can see I had to actually support and match the the schema that I went and created with CQL. So I send you to my blog post to see how that maps actually to the data columns specifically. All right, so that was all fun. So if we flip back to the PowerPoint, we now have. Oh, wait, let me finish that up here. If I go back to source test Java list entry, I didn't do the find. All right, so this is the actual important one. So I want to leverage my data, my schema, my data model to perform a find. Right. So as I said, so we want to be able to search. Santa Claus wants to be able to search at varying levels of granularity. So what I did is I created this method here called find, which can take a row key, which just says nice kids in the USA, a state, and an optional zip. Right. And what I'd do is I'd use that serializer to use what's called a range builder to specify the query I want. So if zip is null, I don't care what the zip is. So I've got a wide range for zip, and I'm just going to specify state. If they specify the state and the zip, then I want equal to the zip. So you do greater than equals and less than equals. So I go on exactly. So let's go test this out. So other than that, it's exactly the same. So I do prepare query, get key with column range, and I specify the range that I constructed here. So we flip over and we do a find, and you can see I'm going to first find for all kids in PA, and then all kids in the 94111 zip. All right, so it found one child in PA, one child in 94111, even though if we look at our data, we actually had 2 in California. So 1 in Pennsylvania, 2 in California. Second query only returned the 1 that was relevant. Cool. So I think we just fulfilled both of our use cases. I'm going to try and speed up here a little bit. Just to show off. Okay, I'm going to do this one really quick so we have time for questions. I'm pretty excited about some of this capability. So what if we wanted to add on a toy list for Santa, right? In a relational world, that would mean create another table, create a join table to it for the 1 to n. But one of the exciting features about CQL3 and Cassandra 1.2 is now we have collection support, which is awesome. So you've got sets, lists, and maps that you can store in your tables. I'm actually going to skip over this bit, and let's just go dive right in. Sorry for going so fast. So what I have here, what I created is the North Pole ++ schema, and check this out. So right here, I changed just my children table to include a attribute toys, which is a set of text. And then you can see this down here. You're allowed to make statements like update children set toys equal toys plus Legos, where child equals Owen O'Neill. So let's quickly blast that in. I'm going to blow away the schema and recreate it real quick. Bam, done. So if we go over here and see what our children table looks like, check it out. So we've got a toys column and Legos in there. And if I quickly grab and say race car, we'll see race car there. So this is pretty powerful stuff. So how do we use this from our Java app, right? So brand new to the scene is, here we go, crank out a DLA, is a SQL driver. So this is available out on GitHub. So it's, again, it's breaking news kind of stuff. Java driver. So you can go grab the Java driver right off of GitHub and build it and start using it. And let me just show you real quick what that looks like. So the CQL Java driver uses the CQL language to perform mutations against Cassandra. So it has this nice little syntax here that allows you to build the query. I think this is called the query builder. So it looks, very similar, a Fluent kind of style. Add toys, a toy, where child ID equals the child ID that I pass in. So I could have just issued the text as well, but this is a nice way to make sure that you're building a syntactically correct statement. So the add toy method just passes those two in. I log both the query and the query builder because I was planning just to see what they look like and how they're different. And to get connected via CQL driver, you just do a cluster builder, add your host, call connect. Here I'm issuing a statement that says use the key space that I want, and we'll just show this working. So in my Palm file down here, you'll see I had to build the Java driver locally and then include it. I don't know if it's been released on Maven repository yet or not. So let me say add toy Chromebook to Owen O'Neill. Run as JUnit test. Boom. And over here, Chromebook. How slick is that? So again, this is partially style. So the CQL driver is supposed to be pretty fast. I personally haven't done any metrics for it yet, but going forward, it is going to be the way that you can take advantage of some of these newer features like operations on collections. To do the same thing I just demonstrated with the CQL driver against in one of the other APIs, I think it is possible. But you basically have to go through the thrift CQL layer in Hector or Astyanax, and basically specify CQL through there. So, so this is just sort of wherever you are on your development, you want to, your development timeline, you want to start paying attention to the CQL Java driver, because I think that's where things are going. Eventually, the Java APIs will probably move off of thrift, but probably not for a long time. But if you want some of the cutting edge capabilities, CQL is the way to go right now. Okay, I think, let me just summarize here real quick. Some shameless shout outs, I think I mentioned, so we've contributed here at Health Market Science, we do a lot of open source stuff. So we've done a Cassandra REST interface for Cassandra that also originally included some MapReduce capabilities. If anyone wants to get involved, we'd love some help on Virgil. You can see it out there. We use Storm here. On top of Cassandra, we used to use Hadoop. So that's what I said. We used to have MapReduce capabilities, but we've actually switched entirely over to Storm. And I'll be doing a webinar on Storm and Cassandra in January. So you can see our Storm Cassandra bolt is out there as well. So I think that's it for me. The code's available here, and I'm on Twitter, and you can hit up my email. I love talking about this stuff, so feel free to reach out.
Thanks very much, Brian.
Back to you.
So, Brian, can you hear me okay?
Yep.
Okay, great. We do have some questions. We've got about 8 minutes left, so let's see how many we can get through. Oh, the question that I'll answer, by the way, I like softball questions. When will the recording be available, and are the slides available from today's presentation? As you saw, there weren't too many slides, but we will have this presentation available within 24 hours, and you will have an email notifying you of that. Okay, so Brian, can we use super columns with composite keys? That's Alex Holmansky.
Yeah, so great question. So to be honest, I know super columns. So the funny thing is, one of the reasons that we chose Cassandra is because super columns were there way back when. But I think composites eliminates the need for super columns. And the recommendation is typically do not use super columns.
Okay, great.
Instead, use composites.
And a follow-up from Alex, can any other client API besides Thrift be used with Cassandra Hadoop integration, i.e. column family input, output format?
Yeah, great question. So right now, no. I haven't looked into the column family input in a while, but that is actually built on Thrift. So there is an issue out there, if you go take a look at Cassandra Jira, to migrate the column family input over to CQL. I'd have to check on the status of that, but I think that's coming soon.
Okay, great. And seeing the Astyanax version of reading and writing, wondering if there is equivalent of Hector template factory kind of abstraction available in Astyanax. Yeah,
so I have not used it. So I have not used that stuff. I believe it's there. So we go one of two ways, right? So with Hector, we do not have objects. So or do any object mapping. So, but I know there is a Hibernate object mapping out there. And then with Astyanax, we use the fluent style with mapped objects. So I'm not exactly sure what kind of templating capabilities.
Okay, and another question, this one from Brennan Huff. Does creating an app in Java have any additional benefit compared to other languages, since Cassandra itself is written in Java?
Oh, that's a great question. Let me think about that. I don't think so, to be honest. So now, with that said, the Thrift API that is out there is Java, and that's what a lot of people build on. But so with Virgil, our REST interface, we actually have some Ruby apps out there. They come in through Virgil, and they're just as good. So I don't think performance would be a reason. So I can't think of any advantage.
Okay.
Of Java,
okay, good.
Unless if you like Java.
Good to know. So basically, code in whatever language you're most comfortable with and use the appropriate.
Right. Yep. Yeah, and there's certainly if you go to if you go to either DataStack's page, or I have a laundry list of just clients. I think there's one in every language.
Yeah, and actually I'm going to give a little plug right now. It's not available as of this moment, but on Monday we are pushing live the new planetcassandra.org community site. And what we're trying to do there is centralize all of these great resources around Cassandra in one spot. So there is actually a pretty nice and extensive client driver library on that. And we're trying to keep track of all the new stuff that's coming as well.
Yeah, perfect.
Okay, well, we are right at the top of the hour. Let me take a quick look down. So upcoming webinars, there's actually one that we're adding on this before Brian's next webinar, which he talked about, which is a streaming topic, CEP, distributed processing on Cassandra with Storm. So the Apache Foundation, the vote is underway right now on when Cassandra 1.2 will be available to the community, and its launch is imminent. We're expecting by the end of the year. So Jonathan Ellis, who is the chair of the Cassandra project, will be doing a webinar, What's New in Cassandra 1.2, on Wednesday the 9th of January. Mark your calendars. That will be at 11 a.m. Pacific time as normal, but a change of day, that will be on Wednesday. Okay, thank you very much indeed, Brian. Really appreciate you spending the time. This will be available tomorrow, the recording, and we'll continue to promote it in the community.
All right, thank you very much. Appreciate everybody attending.
Thank you. Bye-bye.
All right, bye, guys.